Right, the secret to being able to multiply by decimals is knowing your times tables, just knowing all those things that you've been told to learn since since quite a few years ago, to be honest. So let's have a look at some very simple multiplication facts that you should know. Let's try, for example, 3 times 4. If you know 3 times 4 is 12, you will automatically know quite a few new bits of information or new number facts, because you will already know that 4 times 3 is also equal to 12. We can demonstrate that with using an array. So if we have 3's and we have 4 of them, there's another 3, and there's another 3, and there's another 3. Okay, so I have got 4 sets of 3. Look, there they are. There's 1, there's 2, there's 3, there's 4. Okay, so we have 4 sets of 3. 3 times 4 equals 12. We can also think about that as, because we've also can think about it as in groups of 4. Because look, there's a group of 4 there, there's another group of 4 there, and there is another group of 4 there. So those groups of 4, I've got 3 of those groups of 4, so 4 times 3 also equals 12. But we've also looked at how we can use numbers that are similar to those, but are 10 times bigger than those numbers. So if, for example, we know 3 times 4 equals 12, we know that 30 times 4 equals a number that's similar to 12, but because we are 10 times bigger here, our multiplication answer will also be 10 times bigger. So we know that 30 times 4 equals 120. Another thing that we could do is we could do 3 times 40, 10 times bigger, equals 120. And we have done lots of work similar to that. But what happens if instead of making our number 10 times bigger, we make them 10 times smaller? Now 10 times smaller, they are moving the other way, and this is where we're getting into our decimals. So we might have 0.3. 0.3 is 10 times smaller than 3. And if we multiply that by 4, we will still have that 12, but this time we make it 10 times smaller by moving the digits one column to the right. So it would be 1.2. And to demonstrate that movement 1.2, how we got 12 to 1.2, think about our columns that we have looked at. Okay, so we've got 100 column, our tens column, our ones column. 12 fits in here. Okay, if we want to make it 10 times bigger, like we did here, our digits will move one place to the left, and our 110 will become 100. Our 2 ones will become 2 tens, and then we've put a 0 into our ones column to fill that space. So it's 120. But if we are making it 10 times smaller, our 110 and our 2 ones will move in the opposite direction. So our 110 will become 1, 1. And our 2 ones will move into this next column here. And this next column here, you should know, is our tenths column. And we always find in between the ones column and the tenths column, we always find our decimal point. So it's 1.2. Now we can use that to help us with any multiplication with decimals. And once I've wiped my board, I will show you that in just a second. Okay, so let's have a think about a slightly more tricky one. But again, it all comes from knowing your times table. So let's suppose we are doing 6 times 0.8. Let's suppose that is the calculation that you have to try to work out. What can we do to make it easier? Well, to help us with this, the thing that I'm going to use is I'm going to use my knowledge of 6 times 8. because I know my times table. I know that 6 times 8 is 48. Let's put that into my columns. So here's our columns: hundreds column, tens column, ones column. Let's put 48 into it. So it's 4 tens and 8 ones. I want to multiply, but I don't want this one. I'm doing 6 times 0.8, and here our number 0.8 is 10 times smaller than 8. And because it's 10 times smaller, we need to make our answer 10 times smaller. That means that our digits are going to move one place to the right. So my 4 tens are going to become 4 ones. My 8 ones are going to move into this next column there. And remember, that column is our tenths column. We always have in between the tenths column a decimal point. So in between our 4 and our 8, because they're in the ones column and the tenths column, there has to be a decimal point. Our answer is 4.8. Okay, so 4.8, digits are the same, 4 and an 8, 4 and an 8, but because of the position of where they are, they're smaller than the other one, we need that decimal point. Okay. You might even get questions where you are multiplying 6 times 0.08. This time, it's not 10 times smaller, it's 100 times smaller, because this is 8 hundredths. Again, we would have our 48, but instead of moving there, it will go 2 places to the right. And I actually haven't left enough space, so I'm just going to redraw it again here quickly. So let's do them here very quickly. So I've got my hundreds, tens, my ones. We already know that this is the tenths column. Our answer to 6 times 8 is 48, but we're moving it 2 places this time. So this is going to go into this column here, and our 4 is going to go into our tenths column. Still the 4 and the 8 together. This next column is our hundredths column. So how many ones have we got? We haven't got any. Always have a decimal point in between there, 0.48. And you can continue to do this wherever you're trying to solve multiplications with decimals. The way that I was taught hundreds and hundreds of years ago when I was at school is that have a look at how many decimal places that you have in your calculation. Those will be the number of decimal places in your answer. So with this one, there's no decimals here, but there's 1 decimal place here. So my answer has got 1 decimal place, 4.8. This one here, no decimal places here, but I've got 2 decimal places. So my answer has to have 2 decimal places, and this time it will have no ones, no units. So hopefully that will help. Good luck with the rest of the questions.